So I think one common headache on assignment 2 was, how do I compute powers with a loop, Bill? And I mean, I answered that question a few times. We talked about that with some people. It was a tough one, computing powers with a loop. But I think we're sick of it. So let's talk about computing powers some other way. So I want to compute, just like I did in the lecture a couple of weeks ago, the value 3 to the n. So for example, if I wanted to compute 3 to the 3, that would be 3 times 3 times 3. And if I wanted to compute 3 to the 4, why can't I draw the number 3? If I wanted to compute 3 to the 4, that would be 3. I think I should re-record the video with a different number. 3 times 3 times 3 times 3. In fact, actually, wait a minute. This looks a lot. 3 to the 4 looks a lot like 3 times 3 to the 3. But of course it is. That's how we compute powers. 3 to the n equals 3 times 3 to the n minus 1. And also I should observe that 3 to the 0 equals 1. So we know that. And it looks a lot like I'm staring at another one of those recursive decompositions. So if I want 3 to the power of n, all I need is some way to get 3 to the power of n minus 1. And I just take that and I multiply it by 3, and then I'm done. So maybe we could implement that over here. And it sounds great because maybe I won't even need a loop for that. Okay, so I want to compute 3 to some power. And it points out if our result is going to be an int, we can't really work with negative powers because they're going to be fractions and we have no way of storing those in an int. So it says if n is negative, if n is less than 0, then we just return 0. We just give up. If n is equal to 0, well, 3 to the power 0 equals 1. All right. Otherwise, what do we want? Well, okay, let's get 3 to the power of n minus 1. We'll call that previous power. So how do I get 3 to the power of n minus 1? If only there was a function somewhere in my program that computed powers of 3. Oh yeah, there it is. Power 3. Okay, so we'll call that previous power equals power 3. I want the power of n minus 1. And then my result is just 3 times the previous power. So we'll try that out. And down here I've got some testing code. We'll start with 3 to the power of 5. All right, 243, and you can check. It turns out that that's correct. Let's try 3 to the power of 8. We computed that in the lecture, and it was 6561. All right, looking good. And notice that just like before, even though it's a bit conceptually more hazy, for some reason the code I write is just dead easy. It's almost cheating. There's no need for loops. I barely even need any variables. All I need to do is to find a way of breaking down the problem so that I turn the version for n into a slightly more, like I am able to simplify it down to the version for n minus 1 with 1 or 2 extra steps. And so I've implemented a recursive way to compute powers. And so my answer to the question of, do we need to use a loop to compute powers? Well, you can. Turns out you don't have to.